Hey everybody, let's explore elastic collisions. So this is a special case where both momentum and energy are conserved in a collision. So for example, let's say this way is positive. So we have two masses that collide, and let's say we are given both masses and both initial velocities. So if we're given this, solve for the final velocities. Okay, so what do we do? For any collision, momentum is conserved. So momentum is conserved. The momentum initial is the same as the momentum final. Right, so we have this one equation for the collision. Special case, if we assume it's elastic, then also energy is conserved. Okay, so we have two equations, two unknowns, so we can solve it. So let's get to the details. Momentum is conserved. So before the collision, m1 v1 initial plus m2 v2 initial. After the collision, m1 v1 final plus m2 v2 final. Okay, and then these are the unknowns because we're given all of this other stuff. Okay, so for energy, if the datum is here before the collision, it's still there after the collision. They didn't change. And this is true even, let's say, if you have an object going this way and an object going this way. Immediately before the collision, let's say it looks like this. What does it look like? And then let's say for M1, the datum is here. And then for M2, the datum is here. And then this is what it looks like immediately before they collide. What does it look like immediately after the collision? It looks like this, right? So before the collision, immediately before the collision, and immediately after the collision. Each mass is at the same datum. So the gravitational potential energy wouldn't change during a collision, only the kinetic energy. So for kinetic energy, before 1/2 m1 v1 squared, and then for the other block, 1/2 m2 v2 squared, and then after the collision, for this one, 1/2 m1 v1 final squared, and for this one, 1/2 m2 v2 final squared. And the unknowns are these final. Right, so here we go. Two equations, two unknowns. You can solve. Let me give you some hints with the algebra here. So I'm gonna move m1 on the left side of the equation, and then I'll move m2 on the right side of the equation. Okay, and then I'll do the same here. I can multiply everything by 2 to get rid of the half. So I'll have m1 on the left side. And then I'll move m2 on the right side. So this goes on that side. Okay, and then, you know, if you have a quadratic like this, it's the same as if you do this, right? And then this quadratic, v2 final minus, and then v2 final plus. Okay, and then now take a look at this. M1 times V1 initial minus V1 final. That's right here. Take a look at this. M2 times V2 final minus V2 initial. That's right here. Right, so look, if these are equal, and they're non-zero, these are equal, so you can cancel them, right? You divide through by the same quantity, non-zero quantity, which leaves us with the leftovers, right? So the leftovers, V1 initial plus V1 final, V2 final plus V2 initial. So now, maybe try it yourself right here. Given these two equations, equation 1, equation 2, solve for these two unknowns, V1 final and V2 final. Okay, so I'll pause here, and then you try it. You can pause here, but then let me work it out. Okay, so let's just do substitution. So let's say I want to solve for V1 final first. So I'm going to write an expression for V2 final right here. V2 final equals, I'm going to move this on the left side. Okay, so this is V2 final. I just simplified this one. And then now I'm going to substitute this there. Okay, so let me do that. Okay, so V2 final is all of this. Right, and then the rest of it. Right, and now the only unknown is here. Okay, so you notice the common theme throughout physics is always keep an eye on what is known and what is unknown, because I'm just going to take all of this and move it on that side, and I'll take this and move it on this side. So let me do that. I'm going to move this on that side. Okay, so let me write this out. And then let me just write everything out first. Minus, there are two of them. Okay, and then let me keep an eye on my unknowns. So that means I'm going to take this and move it on the other side. Then I'll take this and move it on this side. So let me do that. Minus M2 V1 initial. Then this turns into a plus 2 M2 V2 initial. Take this and move it on that side. Okay, and then just divide by this. Let's see, how about I gather terms right here? So that would be M1 minus M2 over M1 plus M2 V1 initial, and then this 2M2 over M1 plus M2 V2 initial. So see, the final velocity for block 1 is a function of, right, it depends on the initial velocities and the masses. Okay, now let's try for V2 final. So let me copy these where I have more space. Okay, so back to these two, right? So last I solved this for V2 final and then plugged in there. This time I'm going to solve this for V1 final. And then take this and plug it in here so that I can solve for V2 final. So I'm going to take, I'll take this and put it there. So let me write that out. M1 V1 initial minus this. So let's be careful with that minus. So minus plus. Okay, and then the rest of it. All right, and then let me keep an eye on my unknowns. Here, here. Okay, so let me just multiply this through. So M1, okay, there are two of these, two of those. And then minus, minus. Okay. And then my unknowns are here still, which means I'm going to take this and move it on that side, and I'm going to take this and move it on this side. Okay, so then I just divide both sides by that. And let's see, let me gather some terms over here. So, okay, so for V1, I got 2m1 over m1 plus m2 v1. And then, let's see, right here, plus m2 minus m1, like just looking at this, v2 initial. So here we go. Okay, so again, the final velocity is a function of the initials plus all the masses. Okay, let me just put them together on the same screen. Okay, so it looks like this. And again, this is only for elastic collisions. Specifically. Okay, so try and practice this algebra yourself. So any collision, it's just this type of algebra, and then you just figure out what's known, what's unknown, and plug in the numbers, and that's all. Okay, so just keep practicing, and I'll see you on the next video.